Welcome fellow learners. In this video, we will learn how to implement an end-to-end custom SQL agent which consists of dynamic few sort prompting with the recently released open source LLM Llama 3.1 on a local system. Additionally, we will learn how to incorporate persistent memory management through multiple session chat histories by utilizing a local SQL database. So let's first write down all the different steps that we are going to follow in this notebook for this implementation. Firstly, we will do Langsmith configuration. Langsmith helps in understanding all the intermediate steps that the agent was involved into. In the second step, we are going to import the LLM. For the LLM part, we are going to use Llama 3.1 instruct version quantized to 4-bit to seamlessly run it in our local system. In the third step, we are going to import the data. For the database part, we are going to utilize the Chinook database, which I have already utilized in my several other videos. This database consists of multiple tables. In the fourth step, to make this SQL agent more effective and deployment ready, we will learn how we can implement dynamic few sort prompting using Langchain. In the fifth step, we are going to create few custom tools that we are going to utilize with our SQL agent. And in the sixth step, finally, we are going to create an SQL agent executor by passing our React agent to it. In the seventh step, we are going to create a persistent memory management by utilizing a local SQLite database. And finally, in the last step, we are going to create a Gradio user interface to make this application user friendly. So let's get started with the implementation part. So in the first step, we are going to configure this Langsmith. Langsmith is a platform provided by Langchain, which we can utilize at every step of a generative AI project pipeline. So like we can utilize it in tracing, debugging, and even in testing. So I have created a separate video on Langsmith. So if you want to learn more about Langsmith, I have created a video named Getting Started with Langsmith, where you can find out how you can install it in your local system and then how you can utilize in your particular project. So for this particular implementation, we need to pass few parameters to configure this Langsmith. The first one is Langsmith API key. The second one is we need to pass this tracing parameter as true. And then we need to define a project under which we need to trace all the different intermediate steps. And then finally, we need to also pass our endpoint for this Langsmith. So let's run this cell and we will be done with configuration of this Langsmith. In the second step, we need to import our LLM. For the LLM part, as I have already told, I will be utilizing this Llama 3.1 instruct version quantized to 4-bit. We are going to utilize Ollama. So Ollama is a platform which helps us to utilize these open source LLM in a quantized version such that we can easily run it in our local system which are having less compute resources. I have also utilized Llama 3.1, but for this particular implementation this was not giving that much good result, due to which I have used instruct version of this Llama 3.1. So let's run this cell and this Llama 3.1 will be imported in this particular notebook. So in the next step, let's import our data. We are going to utilize this Chinook database. This database consists of 11 tables, and we are going to utilize this data to create this custom SQL agent and testing out this custom SQL agent. So let's run this cell. We can also print the schema of different tables by utilizing db.tableInfo. So let's do that. Do db.tableInfo, and we can see these are the different tables, their schema, and 3 rows from those tables. Now we have configured Langsmith. We have imported Llama 3.1 LLM and also imported this database, Chinook database, into this notebook. So in the next step, we will see how we can utilize dynamic few sort prompting in this custom SQL agent. There are two major benefits of using dynamic few sort prompting in your SQL agent. The first one is you will make sure your LLM has more understanding of user's query by providing few examples which are related to the user's query. And the second one is you will save cost by providing less tokens to your LLM prompt. So if you see, I have created few examples over here. So like the examples are like list all customers from Canada, and the output is select star customers where country equals to Canada. Similarly, I have created some other examples over here. So let's run this cell and you can see I have created total 10 examples over here. In our use case, we want this agent to use user's query in a natural language format, then convert that user's query into a SQL query, and then use that SQL query to fetch data from database, and finally give user a summarized result. So now you might be wondering how this will work. So firstly, we will convert these 10 examples into embedding format. For the embedding part, we are going to utilize open source embedding model. Then at runtime, whenever user asks a query, we will first convert that query into embedding format by utilizing same embedding model, and then use a similarity search algorithm to find out top k examples out of these 10 examples, and then pass those k examples along with our prompt such that our LLM has better understanding of user's query. So for the embedding part, we are going to utilize this open source embedding model mini-LM, as we are running this SQL agent completely on our local system. For that part, we are going to utilize this open source embedding model such that we can run it in our local system. So for that part, we are going to utilize this Hugging Face embedding model, and then we can get this mini-LM embedding from Hugging Face. So once we have this embedding model, we can utilize this semantic similarity example selector from Langchain. What it will do, it will use this similarity search algorithm and the embedding model to get the top k examples from these 10 examples. So like we need to pass these few parameters to it. The first one is all the examples. The second one is the embedding model. The third one is FAS. FAS is basically a vector database. This will be utilized to run this similarity search algorithm. Then k equals to 2. This is the number of examples that we want to fetch at runtime. Then the last one is input keys. So if we scroll a little above, you can see the key over here is input. So we need to pass that over here also. So let's run this cell. Then after this, I have asked a simple query to it also, like how many artists are there, and it has fetched like these few queries from those 10 examples, like how many tracks are there in the album with ID 5, how many employees are there, and so on. So now we have created this semantic similarity example selector. Next, as we are going to create a custom SQL agent, we need to create a prompt which has a general description along with the tools description. So like you can see, I have provided this general description like you are an agent designed to interact with a SQL database. Similarly, I have passed tools description over here. So these tools will be SQL tools. So let's run this cell and it will create our prompt. Then we can utilize this few sort prompt template to create that few sort prompt template, and then utilize this chat prompt template to create a complete chat prompt template. So let's run these two cells and our prompt creation part will be done. Now for the tools part, I have created these custom tools. The first one is this query SQL database tool, which will be utilized to run our SQL query. The second one is this info SQL database tool. This will be required to fetch schema of those tables. Third one is list SQL database tool. This will be required to list down all the tables in the database. And fourth and final one will be query SQL checker tool. This will be required to check the query generated by LLM. So let's run this cell, and after this you can see I have also passed a query to this prompt, and you can see this complete prompt has been created. So like at the start you can see this is the initial general description that I have provided. And after that, this is the tools description that it has been passed to this prompt. And then finally, the React logic over here. As we are going to create a React agent, which will first reason it out and then act according to the reason. So like you can see, this is the kind of React logic that has been provided to this prompt. So now we have done with the prompt. We are also having our LLM. We are also having our database. So let's create a agent executor, which we are going to utilize to run this particular SQL agent. So you can see I have used this create React agent module provided by Langchain, and then pass that create React agent to our agent executor to create a agent executor. So let's run this cell, and our agent executor will be created in this particular notebook. Now we have created this agent executor. The only missing part is history. For the history part, we are going to create a persistent history memory. For that part, we are going to utilize a local SQLite database. So if you can see, I have utilized this SQL chat message history module from Langchain and pass these three parameters to it. The first parameter is session ID. This will be required to make those sessions mutually exclusive, such that one session doesn't have any information about other session. The second parameter is this connection, where I have passed the database name over here. The third one is this table name, where we are going to save our chat history. So by utilizing this get session history at runtime, we will pass a session ID to it, and it will utilize that session ID to save our chat history. And one more thing, you can see I have utilized this last k messages equals to 4. So we are going to utilize only last 4 messages from chat history to pass it to our LLM, such that our LLM doesn't get biased to old histories and it have more weightage to the recent history. After that, you can see I have used this runnable with message history module from this Langchain and passed our agent executor the get session history function and then input message key and history message key over here. We will be utilizing this runnable to run our SQL agent. So let's run this cell. Now we have created this runnable where our history is managed and also it has our agent executor. So the final part is creating a Gradio user interface. So creating a Gradio user interface is really simple. You can see I have created a chatbot, then input message where user's query will be written, and a clear button where user will basically click on that clear button and all those entries will be removed. One important thing over here is state. So this is the state object which will keep a track of our session ID. So like whenever user create a different session, this will pass a different session ID. So as you can see, I have created this UID session ID which will be different for every new session. And according to this, it will make those sessions mutually exclusive. So let's run this cell and it will create a Gradio user interface for us. So now we can click on this link and it will open a Gradio user interface. So here we can enter our queries. So let's say ask a simple query like how many total artists are there. As it is running in our local PC, it will take a while as we do not have that much of compute resources. So let's wait a while. So now you can see it has provided us the result. The result is correct, like 275, but it has also along with that 275 there is some gibberish result. So let's ask a little difficult query like provide top 5 artists with most number of albums. Let's wait and see how does this gives us result. Meanwhile, let's go back to our code. And over here you can see at start the session ID was this and chat message history was empty. And when we asked the second question, session ID was the same as we are in the same session, but the chat message history has been given the initial question that we have asked to this. So you can see it has given us this result like there are top 5 artists with artist ID which has 21 albums and the artist ID 22 which has 14 albums. So like we have got a good result. Now for the multiple session part, let's copy this and create a new session by pasting it in new link. And if we ask the same query like this query which we have asked earlier, as we have seen when we asked it in this session, it was having a chat history. And let's see does this have chat history when we are creating this new session or not. So let's go back to our code and now you can see it has created a new session ID and the chat message history is empty. So let's go back to our UI and here you can see it has provided the same result. So like artist ID 90 with 21 albums and over here it is also same artist ID 90 with 21 albums. So result is the same but formatting is a little bit different. One more thing that we have missed is like we have also used that Langsmith and for the Langsmith part you can see it has created this local SQL agent project in that Langsmith and you can see all how many total tokens it has used, what was the latency and all. So you can see like it has used around 17,000 total tokens. If you click on this local SQL agent, you can see all the intermediate steps that it has used and all the calls that it has used to call the LLM. So if you click on this, it will provide you all the information about all the calls that it has made to our LLM. So like this one was the first query that we have asked to it. This the second one is basically the second one and all the result that it has provided. You can see all the runnable sequences that it has utilized, all the runnable calls over here also. In this way, we can create a complete end-to-end custom SQL agent by utilizing this open source Llama 3.1 completely in our local system. So you can try it out. You can utilize your own data set and test out this local SQL agent and have fun learning. So great. Thanks for making till the end of this video. Goodbye until the next time.